Right. So I just wanted to clarify something for Serena. So Serena, this weekend confused you?
No,
Tell me if it confused you, if you understood it.
it was a bit confusing at first, but I kinda understand it now.
Okay, well,
Mm,
you feel like you still want me to go like run through with you?
yeah,
Okay. So tell me, Serena, what's the general form of a quadratic?
ax squared plus bx plus c.
Right. Now A, B, and C, and we could agree that they could be any number.
Yes, sir.
So A, B, and C belong to the element of real numbers. Um, Zachary, and you understand that a quadratic could look like you could get a quadratic and it could be 3x squared plus 5x plus 2. You could get one with 5x squared plus 7x minus 3. You understand? Tell me if you understand now,
Yes,
Zachary.
sir.
All these
Yes, sir.
aren't all of those quadratics,
Yes, sir.
and all of them would have different values for A, B, and C.
Yep.
So A, B, and C could be any number. Get that in your head. It could be any number, right? So Serena, you okay with that part, right? Don't let the A, B, and C confuse you. They could be any number, right?
Yes, sir.
Serena. Now, Serena, you remember what had happened when we was trying to do the diagram for the questions whose coefficient for x squared was more than 1? Let me show you what I mean. Do you remember what happened when we tried to do the diagram for which one, boy? You remember what happened when we tried to do the diagram for the 3x squared one?
Yes, sir.
It's kind of a bit crazy. It was a little bit crazy.
Yeah,
Yeah, so what did we actually do to work it out?
we had to divide the whole equation by 3 to get the coefficient of x to be 1.
Exactly, because Zachary, what's easier to work with? 3x squared? Because remember, Zachary, your main objective here, you're going to take the shapes and you're going to rearrange it into a square. Do you think it's easier to work with three big x squareds, or do you think it's easier to work with just one big x squared?
One big X good, sir.
For sure. So that's the concept going into this, right? So Serena, do you understand that we don't want to have anything other than one?
Yes, sir.
All right. So if I want to get rid of the a in front of the x squared, what would I do throughout?
Divide everything by a.
Right? If I do that, what would I end up with?
F of x over a equals the x squared plus b over ax plus c over a.
All right. And how much big x squared do we have now?
1.
Right. So I'm going to draw a big block of x squared. And Serena, isn't our main objective here to make our square somehow?
Yes, sir.
Right. So this is x squared here. Right. This is x squared. Each length would be x. So this length here is x. This length here is x. Now, Serena, if I have a shape b over a by x, so I know it's confusing, Serena, but you see b over a, that would also be a number. So think about this, Serena. If you had 7x, how could you represent that as a shape?
7 blocks of x.
Say that again.
7 blocks of x.
7 blocks of x, right? And each block of x would be 1 by x cent, or you could think about it like x by 1. Yeah?
Yes, sir.
And another way you could think about it is x by 7.
Yeah.
That would still be 7x, would it not?
Yes, it would.
Okay. And if I cut that in half, what would that be?
It would be x by 7 over 2.
Right. And that'll be 3.5x cents.
Yes, sir.
I want you to keep all of these concepts in mind. So you see how we have b over ax? I could represent that as a rectangle with a length of x here, right? X, both of the dimensions are x. And what do you think I could use for this dimension? If I want to get back b over ax.
It would be half of b over a.
Wait, not so fast. I'll write b over a for now, right? And I'll put back the plus c over a. That's our number. C over a is a number. We will recall that just now. So, Serena, do you understand that we successfully took the algebraic expression and we drew it out as in a diagram form? So this is x squared. This would be b over ax, and well, c over a, just c over a. So how much you follow so far?
Yes, sir.
Okay, Zachary, do you follow?
Yes, sir.
All right, Caleb, do you follow? Or like you're real confused?
Hello, confusing.
All right, so Caleb, do you understand the last couple of classes I had with the diagrams? And like how we rearrange it to make a square?
Yes, sir.
Okay. So Caleb, if you go into rearrange shapes to make a square, do you want more shapes to work with or less shapes to work with?
Less.
Less, right? Okay, so Caleb, A, B, and C, them they could be any number, right? They could be any.
Yes.
So let me get an example. I could have x squared plus 7x plus 2. And Caleb, if I have that, what would A be there? What would A be over there?
A is X.
No, A is 1.
Well, one here.
Because how much x squares is that?
1.
Right? So that's 1x squared. Okay, so A is 1. What's B by chance? What's B?
7.
What's C?
C. 2.
2. Okay. So in this example I gave you, x squared plus 7x plus 2. How much blocks of x squared would I have?
1.
I would have 1, right?
Yeah.
What if I had 7x squared plus 3x plus 5? How much blocks of x squared would I have?
7.
7. Which one do you think? Like, okay, I would have to draw 7 blocks of x squared.
Yes, sir.
And then I would need to figure out how I'm rearranging all of these shapes to make a square. You don't think that's a headache?
Yes, sir.
So would you rather have 7x squared or 1x squared?
1 X squared.
I agree, right? So Caleb, if this is the general form, right? A, B, and C could be any number. What do you think I should do throughout to cancel off with this A? So I only have a 1x squared.
Divided by A.
Right. If I divide everything by A, the A is going to cancel off here.
Yes, sir.
So now I have a 1x squared. So Caleb, x squared. What is x squared? If you're thinking about x squared as a shape, what kind of shape comes to mind? X squared.
I don't know.
Okay. Think of 5 squared. What kind of shape comes to mind if you see 5 squared?
5 squared.
What kind of shape comes to mind? If you had to think of a shape whose area would give you 5 squared, what shape do you think of? A rectangle, a square?
Square.
A square, right? And you would say that the length, one of the lengths is what?
Wait, no. No.
So the area is 5 squared. A is equal to 5 squared. So what would the lengths be?
I don't know.
The lengths would be 5. Because how do you find the area of a square, Caleb?
Like I said.
Exactly. So what's 5 by 5? Wouldn't that just be 5 squared?
Yes, sir.
Yeah, so 5 squared would represent a square. What about 7 squared?
It could represent a square too.
Exactly. And what would the length for one of these sides be?
7.
Exactly. And the area would be what?
40.
49, right?
Yes, sir.
You said 14. How do you find area? Remind me, how do you find area for a square?
7 will number squared.
You're gonna
Side.
You're gonna multiply the side by the side. So the side squared.
Yes.
So Caleb was so each of these side is 7. What's 7 by 7?
Boy, man.
And that 7 by 7, and that's the same thing as 7 squared.
Yes, sir.
I mean, in the name, like 7 squared, 5 squared. Sound like a square, right?
Yes.
So, Caleb, if I had x squared, what kind of shape comes to mind?
Square.
And what would the length for one of the sides be?
1, 4, right. X,
Right. And if you multiply x by x, we're going to get.
X squared.
Yeah. You understand it?
Yes, sir.
Okay. So, x squared, this would be represented as a square with lengths x and x. And if you find the area, remember we again.
X squared.
Okay, great. Now we need to represent b over a x as a shape. Now, do you think this would be a square or a rectangle?
Rectangle.
I think it'd be a rectangle, but you're probably confused about why is a rectangle. Now, Caleb, for a shape to be a rectangle, for a shape to be a square, right?
Yes.
The
It's
length,
a square.
should I? Yeah, it must have a square, number one. And the second reason is because, Caleb, if it's a square, aren't the lengths the same?
If what?
If a shape is a square, doesn't that mean the lengths are the same?
Yes, sir.
Okay, so x squared, isn't x squared x by x?
Yes.
Isn't x the same?
Yes.
Okay, so over here we multiplying b over a by x. Is b over a and x the same thing?
No.
No, it isn't. Think about if I had this shape over here, right? Think about if I had this shape. Let's just say that's 2 and that's 5. What would the area for that shape be?
Yeah. 5, right.
5 by
2.
5 by 2. Because it's a rectangle, right? Length by width. Understand?
Yes.
So if I had this shape here, 7 by x, what would the area for that shape be?
That one, right.
7x. So if I had this shape over here, b over a x, what would the area for that shape be?
B over X.
Right. So you understand how I come up with this shape from that?
Yes.
Nice. And well, c over a is a number. We could just plop it down there for now. We go. Remember it when we finish. Figure out it for now. So you understand how we come up with these shapes, yeah or no?
Yes, sir.
Okay, good. And if you're ever confused, don't be scared to stop me. I don't bite. I'm very, very friendly. I'm a chill guy. You know how to feel any kind of way. Just stop me and I'll explain it to you. All right. So this area is x squared. And if you were to find this area, it would be b over ax. Okay. So Caleb, you see these two shapes here? You see these two shapes?
Yes, sir.
We need to figure out how we're gonna make our square with those two shapes. So I'm gonna put down this shape here. I'm gonna put down this shape. So we have this shape. I'm gonna put it back here. Right? I'm gonna put this shape over here. Now, Caleb, if I take this shape and I bring it to the side here, does that create a square?
No, sir.
No, it doesn't create a square. But Caleb, if I cut this shape in half, if I were to cut this rectangle in half, how much shapes would it make? Come on, Caleb, if I were to cut this rectangle in half, is that 2?
Yes.
I agree with you 2. So you're gonna put 2 rectangles, and these rectangles, would they be identical?
Yes.
Yeah, they would be identical. What would be their length? What would be the length for them?
B over A X.
No, the length.
X.
It'd be x, right? X for both of them, correct?
Yes.
Okay, but oh, if the original length here was b over a and you cut it in half, wouldn't that be half of b over a?
Yes.
Think about it like this. If this length was 4 and you cut it down the middle, what would be the length for one of the halves?
2.
2, right? So you need to find half of b over a. So all you're going to do is you're going to say a half multiplied by b over a. What would a half by b over a be?
You right.
B over?
A.
No. Well, so 1 by b is b.
2A.
Right. B over 2. So Caleb, you'd end up with two identical halves, and the length for this dimension would be b over 2a, right? B over 2a here and b over 2a. Did I confuse you like really bad?
Now,
All right. And Caleb, what do you think I'd get if I add up b over 2a and b over 2a?
B over 4. Well, 2B over 4.
Mm-mm. So Caleb, check the concept again, right? Check the concept again. If this length was 4 here, and you go and cut it in half, what would be the length here for one of the halves?
2.
And the other half? If you add 2 and 2, what are you supposed to get back?
4.
Okay. So if you cut b over a in half, right? And you get b over 2a and b over 2a. If I add them back, what am I supposed to get?
B over A.
Yeah. Watch. Do they have the same denominator?
Yes.
That means I could add the top, right? So Caleb,
Yes.
if I have 1b here and 1b here, if you combine 1b and 1b, how much b's you would have now? If you add 1b to another b, how much b's you have now?
2B.
Right? So b plus b is 2b, and I'm gonna write back 2a. Notice the 2 would cancel off.
Yes.
So you get back b over a. So I cut the shape in half, and I ended up with 2 equal rectangles with a dimension of b over 2a on top. Be real honest with me. Am I confusing you?
Mass.
All right. Good. Serena, can you see how you might be able to get a square from here now?
Yes, sir.
So Serena, tell me what to do with these two halves.
You take one half. Oh gosh. Yeah, put it there, and then you flip the other half so it be horizontal and put it at the bottom.
Yes. Yes, indeed. Okay, great. All right. So Serena, can you remind me what the dimension for this square was?
X.
Right? And Caleb, can you remind me what the length for this dimension was?
B. Well, B over 3.
B over 2a, yes. So Caleb, what would be the total dimension then? What would be the total dimension?
X and B over 3.
X what?
X and B over 3.
Yeah, correct. Because Caleb, if this length was 5 and this length was 2, and to combine it, you'd say 5 plus 2.
Yes.
It's the same concept. This is X, adding that to B over 2a. Great. Now, Caleb, if we did make a square, right? The length should be the
Yeah.
okay. So Caleb, if I work it out, what should this length also be?
X. X. Okay.
So
Wait,
that
X and B over 3.
yeah, you're correct. If it's a square we made, then this should also be X plus B over 2a. So let's see. Right? Caleb, remind me, what was the dimension for this side of the square? It was X, right?
Yes.
And what would the dimension for this?
B over 3.
Right. Did we make our square then?
Yes.
Yeah, we did make our square. Zachary, you okay with everything I've done so far?
Yes, sir.
Okay, so you see, by splitting, by us splitting the b over ax rectangle in half, I was able to get I was able to get two equal smaller rectangles, for which I could have taken and placed to the right and one to the bottom. And that formed a quote unquote perfect square. So Serena, you're okay up to this point, right?
Yes, sir.
Okay, so Serena, you probably realize that it looks like a square, but is it like a perfect square?
No, sir.
No, it's actually missing this small piece over here, correct?
Yes, sir.
So we need to figure out the area that we're missing. How would we figure out the missing area?
You find the area of the square and then
Try talking a bit louder. I'm struggling to hear.
you'd find the area of the square that you're trying to complete and then subtract. Um, I forgot what you're supposed to subtract from it.
Not quite.
No?
Not quite. Because you'd be going around in a circle there. Think about it like this, right? Serena, so you're saying to find the area of the big triangle. I mean, what's in triangle? You want to find the area of the big huh, I'm real tired. You want to find the area of the big square. That's what you're saying, right? And then from you would subtract that from this area. That's what you're saying, to get this missing piece over here or not.
Yes, sir.
Okay, but that's a lot of work. I think, look carefully, Serena. How would I find the area of this small square over here? It's not that deep. And it's easier than you think.
You would multiply 2a by, I mean,
So you could do x plus b over 2a squared.
X plus b over 2a squared would be for the entire square, right? But we want to figure out the area of the missing square. Because, Zachary, watch, you'd realize that, look at the diagram. Something is missing, right? This don't look like a perfect square. And you're seeing something missing?
Yes, sir.
Yeah, this small piece over here is missing. I actually need to find the area of this missing piece.
so you'd multiply b over 2a by b over 2a.
Yes, that is it. Because, Caleb, what was this dimension again?
Which one, sir?
What was this dimension?
B over 2.
Right, and Caleb, what is this dimension?
B over 2.
Right, so Caleb, if I want to find the area of this square over here, how would I do that? So Caleb, I have a small square over here, and the dimensions are b over 2a, b over 2a. How would I find the area of that square?
B over 2 squared.
Yeah, yeah. You're not wrong. See, so you would say b over 2a all squared, right? You're not wrong. But an even simpler way to think about it is, Caleb, and I'll just have to multiply b over 2a by b over 2a.
Yes.
Okay, so what's b by b?
2B.
No, wouldn't be 2b.
B squared.
B squared, yes. Okay, so we have 2a by 2a. Let's work it in parts. What is 2 by 2?
4.
What's a by a?
2. Whole squared.
Right. So the missing area is actually b squared all over 4a squared. Zachary, do you understand?
Yes, sir.
Okay. Serena, what about you? Do you fully understand that?
Yes, sir.
Okay. So Serena, if we want to write back our expression, let's just reformulate it. So Serena, you understand what we have here is not f of x, it's actually f of x over a. Do you understand that part?
Yes, sir.
Okay. And to represent it algebraically, we would say it's this big square minus the missing area. Because when we actually did this, we actually got this. So we need to actually find for that. Tell me if you're confused.
No, sir, I understand.
All right. So again, Serena, you understand that when we drew it, this is what we actually was dealing with.
Yes, sir.
So to figure out the actual area we had, we need to find the area of the entire square and subtract the missing area. So that would be, so how would I find the area of the big square that we created?
You would square the length that you found of these sides, which is x plus b over 2a.
Right? And Caleb, what was the missing area?
B squared over 4a squared.
Right. Caleb, if you're missing something, do you think you should put positive or negative?
Negative.
Yeah, because you're missing it, right? You don't have it. So negative b squared all over 4a squared. But guys, I'm forgetting something. And you only can tell me what I'm forgetting. I said we go deal with it.
C over a.
Yeah, we had to put back that c over a, right? Plus c over a. Serena, you should be able to see that it's forming. It's starting to look like the completing square form. You've seen it, Serena?
I think so.
Okay. Let me continue then. Right? So Serena, you see these two fractions over here?
Yes, sir.
Would I be able to merge it? Combine it? Is it possible for me to do that?
I'm not sure.
You said no?
I'm not sure.
You're not sure. Okay, if I had 1 over 7 plus 1 over 5, would it be possible for me to combine those two fractions?
If you find a common denominator, then yes.
Okay, so would I be able to combine these two fractions? The answer is yes. Yes. A common denominator is just a number that both denominators could go into. So I feel like that part confused you. So let me run that back and it'll make sense for you. Let me do some SCA maths for a bit. So Rena, if you wanted to find the LCM of this, give me a possible LCM.
12.
It's at 12.
My bad. My
Whoa,
bad.
whoa, whoa.
35.
Whoa. 35, right? And why did you select 35? And 35 was the smallest number in which 7 could go into it and 5 could go into it.
Yes, sir.
Zachary, do you understand why we selected 35?
Yes, sir.
Right. Okay. Caleb, Caleb, what about you? Do you understand why we selected 35 was the LCM for this particular question?
Yes, sir.
Okay. Caleb, would 70 also work for the would 70 also work as a common denominator?
I would say yes.
I would say yes as well, right? But is it the lowest common multiple? Is it the
No,
small?
sir.
Nah, it's not the smallest number 7 and 5 will go into. The smallest number will be 35. So you're always trying to find the lowest common multiple. And again, guys, the lowest common multiple is the smallest term in which both of your denominators could go into without leaving a remainder. So let's apply that concept over here now, right? So we have minus b squared all over 4a squared, right? Plus c over e. Right. So Caleb, what are our denominators in this question?
4a squared. Mm, 8.
4a squared and a. Okay. Serena, could you think of an expression in which 4a squared could go into and a could go into?
4a squared.
Yes, that would be correct. Caleb, if you are confused, right? Let me show you something. Caleb, if you had 4a squared, could 4a squared go into 4a squared?
Yes.
How much times?
Once.
Okay. Could a go into 4a squared?
Yes.
Yeah.
No.
Yeah, it
Yes.
could. This a would
Can.
put one of the a's here, and you would end up with what?
4a.
4a. So Caleb, can 4a squared work as a denominator as the lowest common denominator?
No, sir.
Yeah, it could.
4a squared.
Yeah, 4a squared could work because 4a squared could go into it and a could go into it without leaving a remainder.
Yes, sir.
But I feel like you don't fully grasp that as much as I'd like. It's a little confusing with the A and things.
Yes.
I fully understand that. I know it's a little confusing. Trust me, I know it's a little confusing. But let me run it back one more time so nobody is confused. So Caleb, um, what are our denominators in this question? Let's write that down first. What are our denominators?
4a squared.
4a squared and a. Now, Caleb, we are looking for a term or expression that 4a squared could go into completely. And we're looking for an expression that a could go into completely. And let me show you what I mean by completely. Caleb, if you selected 35, doesn't that mean that 7 could go into 35?
Yes, sir.
How much times 7? 7 could go into 35 how much times?
7. 5 times.
5 times. Great. So let me show you something, right, Caleb? Let's just say we use 4a squared. If I do use 4a squared, then this condition needs to be met. I'm whatever, like you see how we put 7 over 35, 7 over 35 here, and we got a nice answer.
Yes, sir.
We need to get a nice answer without leaving a remainder. Caleb, let's just say for instance of 35, I use 34, right? Would 7 be able to go into 34 completely?
No, sir.
Nah. It's the same concept over here. I promise it's the exact same concept. It just looks a bit weird. Caleb, if I use 4a squared as my denominator, let's check this out. Caleb, could 4a squared go into 4a squared?
Yes.
How much times?
Once.
Right. So does that satisfy the condition there?
Yes, sir.
Okay, next thing. Could a go into 4a squared? Now, a squared means a by a. So could a go into that?
Yes, sir.
And it would leave you with what?
4a.
Yes. So is 4a squared a suitable candidate for the LCM?
Yes, sir.
Yes, it is. Zachary, are you confused in the slightest?
No, sir.
You see that kind of a little bit of it's just sound a little funny. But you understand, right?
Yes, sir.
All right. Serena, we on the same page?
Yes, sir.
All right, so Serena, how much times 4a squared go into 4a squared?
1 time.
And then you're gonna multiply that 1 by.
The negative b squared.
So what is 1 by negative b squared?
Negative b squared.
Okay. Caleb, I want you to help me with this. How much times a could go into 4a squared?
Once.
Check it out. Check out the work in here.
Yes.
How much times a could go into 4a squared?
4. 1.
Say that again.
What?
I'm struggling to hear what you're saying.
4 times.
Not just 4 times, 4
4.
times. 4 times. Because Caleb, and you have to multiply a by 4a to get back 4a squared.
Yes.
So a could go into 4a squared 4a times. Right? So a could go into 4a squared 4a times. And what am I going to multiply that 4a by?
4A by 8.
Nah, let me go back to SCA maths. If you had 1 over 5 plus 1 over 7, the LCM would be 35. Actually, let me just change that 1 to 3. All right, so Caleb, how would I work this out?
2 plus 1 4.
Say that again?
3 and 1 4.
No. I can't do that. You see how we have different denominators?
Yeah.
You can't do that. If it was the same denominator, only then. So you have to find the LCM. So do you remember how you would find the LCM and work it out?
Yes.
Okay, so tell me, how am I going to figure out what number is going to come over there?
Mm, 3.
Okay, no. 5 into 35 is,
7.
and then you take the number and multiply by the top number. 7 by 3 is?
21.
Right. Work this one out now. 7 into 35 is?
5.
We're going to multiply 5 by.
1.
Right. It's the same concept over here, right? So a could go into 4a squared. How much times?
4 8.
Right. And you multiply 4a by?
C.
Right. And you get what?
4 AC.
Exactly. You get 4ac. Serena, it's starting to come to light. Like you're seeing what I'm talking about. Like it's starting to look familiar.
Yes, sir.
Okay. That's good. Right? Now, if I continue, it's going to give me the form that some of you are accustomed seeing. Guys, and some all you will learn it in school to be 4ac minus b squared over 4a.
Yes.
So,
Zachary, you learned it like that in school as well, and
yep.
okay, watch. You'll see how we'll prove that. You'll see. So Zachary, we just now figured out what you would get if you combine those two fractions. So you get minus b squared plus 4ac over 4a squared. So I'm just going to write my line, and I'm going to write the next line, and then I'm going to continue. So f of x over a, that would be equal to x plus b over 2a squared, right? And Zachary, what did we get when we combine these two fractions?
Um, when you add the b squared over 4a squared plus c over a,
Yeah, what did I get when I combine these two fractions?
you get 4ac minus b squared over 4a squared.
Right. So all you did was you just rearrange it. So you said 4ac minus b squared over 4a squared. That's what you did, right?
Yes.
Serena, does this confuse you by me rearranging it?
No, sir.
Okay, Kayla, what about you? Does it confuse you um if I rearrange it?
This is
Okay, so I can now write plus Thomas Zachary, I can now write plus what?
Case
No, continue. Like, what did we say that this was?
oh 4ac minus b squared over 4a squared.
Okay, we're very close to the finish line, Zachary. Right, so Zachary, we want to find a general expression for f of x. Right now, we have an expression for f of x over e. So what would I need to do throughout to get back f of x?
Divided by a, sir.
No, right now we
Or
have,
multiply by a, sir.
yes, multiply by a. Right? Caleb, if I multiply by E, what's going to happen on the left-hand side? Caleb, if I multiply by A here, what's going to happen?
It um divide
Say that again.
E they multiply it by E
Yeah, if I multiply f of x over A by E, what's going to happen?
will be f of x over E squared.
Mhm. If I had 1 over 5 multiplied by 5, what would that be?
5 over
What's 5 over 5?
1.
Right, so 5 and 5 would cancel off. So just answer the question back now. If I multiply by A, what's going to happen?
Will be f of x.
Yes. Remember, Caleb, we wanted to originally, we were dealing with f of x. That was the original thing. F of x was the original thing. All right. So we need to get back f of x now. And to do that, we decided to multiply both sides by e. So, Caleb, we end up with f of x here. If I multiply this by a, what would I get? How would I write that?
E open bracket x plus E over 2E close bracket squared plus
Nice. Now take your time with this one, right? Take your time with that one. So 4ac minus b squared. Tell me, Caleb, 4a squared. What's another way I could write 4a squared? A squared is the same thing as what?
y
A by A. And we multiplying by A on top end.
what
So what's gonna happen here?
answer
Cancel off both or just cancel off one?
you could cancel it with
No, you can't. How much A's we have here? Tell me, Caleb.
full one by one.
One. So we could only cancel off with one of the A's. Understand? So Caleb, tell me the final thing then. We at the last step. Tell me the final thing.
Like from the answer.
Tell me the final thing here. What's the next line after this? What's the next line after this?
F of x equals E open bracket x plus B over 2E close bracket squared plus 4E take away B squared over 4A.
Right. And guys, we would have just proven the complete in the square form, which is always in the form a x plus h squared plus k. So Serena, if we compare coefficients and we compare terms, right, Serena, what would h be?
H will be B over 2A.
Right, is that familiar?
Yes, sir.
Right. What would k be?
K will be 4AC minus B squared over 4A.
Zachary, you see how we prove it?
Yes, sir.
Yeah. You understand all the steps I did?
Yep.
Okay. Caleb, what about you? Did I lose you like real bad in any particular spot?
That's it. Understandable.
Okay, so guys, this is where the formulas for H and K comes from. So Serena, you're probably not satisfied because you're learning it as C minus B squared over 4A. I feel like you're not satisfied because that's how you learned it in school, and
My teacher didn't teach us this.
oh, if you
Actually,
did,
I have a question to ask you about it later after class.
you have a question to ask me about this later after class?
Yeah, well, I could ask it now.
Yeah, ask me it now.
Okay, so for our coursework, this was before you taught us this, but for our coursework, it had a question where it was in the form ax plus bx plus c, and we had to put it in the form a open brackets x plus h squared minus no plus k,
Mm-hmm.
and the h value was exactly the b value. We we didn't have to like do the formula to find H.
Hmm.
Yeah, that was kind of confusing.
That would never happen. That would never happen. I don't ever see that happening. That would make sense.
Yeah, so
If you get the question, send it to me. But that
okay.
so you're saying that you say tell me that one more time. You said that
I'll send you a picture of the question.
send me a
I
picture of the question one time.
okay, hold on.
Right? Zachary, do you know how you would get C minus B squared over 4A from here? Zachary?
Yes, sir.
Zachary, tell me, how would I get C minus B squared over 4A from this point?
So I'm not really sure.
Not really sure. Okay.
Hmm.
Caleb, you were saying something?
Cancel out the 4A.
Okay, well, you can't just do it like you gotta break it up into parts before you do that. Zachary, if I had 7 over 5 minus 4 over 5, how could I write that? Tell me, Zachary, how would I write that? Zachary, if I had 7 over 5 minus 4 over 5, what would that be equal to?
7 over 4 all over 5. 7 minus 4 all over 5.
Okay, right? I want you to work in reverse now. Let me just say you had something like 8 minus 3 over 9. What was another way I could write 8 minus 3 over 9?
8 over 9 minus 3 over 9.
Caleb, you understand that?
Yes, sir.
Okay, so Caleb, I want you to apply that same concept over here, right? So you see how we have over 4A?
Yes, sir.
We could split it up like this. So if I split it up, tell me what to write.
Um, 4E.
For what?
C.
Mm-hmm.
It already squared.
No, you gotta split it up into parts. You gotta split it up into two fractions. So watch. If you have 8 minus 3 over 9, I could split that up into 8 over 9 minus 3 over 9. So I want you to apply that same concept over here.
Four A C. C.
Say it a little louder. Struggling to hear what you say.
4A C.
4AC,
Over 4A.
right? 4AC over 4A. Mm-hmm.
B squared. Take away B squared over 4A.
Right. Zachary, do you think you could see where we're going with this?
Yes, sir.
Okay, so Zachary, what would be the last line then?
Last line would be that's it.
You're overthinking it. You're real overthinking it. This is real easy. I promise
Um
you're real overthinking it. If I had 5x over 5, what that would be equal to?
if you had 5x over 5, what?
This is an example. If I had 5x over 5, what would that be equal to? If you simplify,
5x divided by 5.
right? But you could simplify it though. You could simplify that. Do you know how you would simplify that?
That's it.
All right. 5 into 5 is 1. 5 into 5 is,
1.
say, just 1x.
Yeah.
Okay. Let me give you some more examples. What about if I had, what if I had x by 9 over x? What do you think would happen?
So you would cancel the x's.
Right, because x could go into x one
Yeah.
time. By 9 is 9. The x's would cancel off essentially.
Yes, sir.
They just get 9. So what would happen over here?
If the A would cancel out itself. The 4 and the A will cancel out itself. 4A will cancel out itself.
Correct. And that would leave me with what?
C minus B squared over 4A.
Yeah. Understand?
Yes, sir.
No problem. Happy that I understand that. You see, like how important SEA maths is? You're probably like underestimating SEA maths, but like a lot of this is SEA maths. Well, fractions and stuff. A lot of it is just fractions.
Yes, sir.
You sure you understand this? Like,
Yes, sir. Yes, I understand.
All right. So, Serena, do you feel okay with the proof now?
Yes, sir.
Okay. So, guys, long story short is anytime you're doing a question, you know how to do this proof. I just show you the proof to take on the plot. You know, like the proof is really cool to know. And you guys are art math students. I think you should know more than regular math students, right? You're probably doing art maths for a reason. Maybe you like maths. Maybe you want to be an engineer or something. You should know more than the average person. So I wanted to show you more, right? But in any general scheme of things, if you get a question, you're not gonna do all of this, guys. All you're gonna do is just gonna use the formulas, right? You're just gonna use the formulas. So let me do a question. So Serena, I'm gonna do the question you sent, right?
Okay.
All right, so Serena, let's do the question. So it was 3x squared. So I'm gonna call it f of x. So let's just say we have f of x, and f of x is equal to 3x squared plus 8x minus 25. First things first, Serena. What is A, B, and C equal to?
A is 3, B is 8, and C is negative 25.
What is the formula for H?
H is B over 2A.
Right? What is B?
8,
What is A?
3.
What is 8 over 6 simplified to?
4 over 3.
Right? And which formula you want to use for K? You want to use 4AC minus B squared over 4A? Or you want to use C minus B squared over 4A?
C minus B squared over 4A.
Sure. Right? C would be minus 25. Right? What would B be?
It will be 8 squared, which is 64.
Right? And was A?
3.
Right. So that's going to be minus 25. What is 8 squared?
64.
4 by 3 is?
12.
Right? 12 into 64. The 12 going to 64? Like completely?
No.
Nah, you gotta simplify the fraction. If you simplify that fraction, we're gonna get
32 over 6.
32 over 6. Say divide 3 by 4. Wait there. 4 into 12 is 3. 4 into 64 is 16. Did you say 16 over 3?
No, I said 32 over 6.
Oh, I just went one step further.
Yeah.
Okay. So you're gonna put minus 25 minus 16 over 3. If you plug that into your calculator, you're gonna get minus 81 over 3, I think. Just verify that though. Let me just do that back in my head. No, you get 91.
Oh, yeah.
It's supposed to be 91. Because this would work out to be minus 75 over 3. And then minus 75 minus 16. 7 plus 1 is 8. 5 plus 6 is 11. Minus 91. Yeah, are you getting minus 91 over 3?
Yes.
Right, Serena, are you guessing that?
I don't have my calculator with me, so I couldn't check.
Serena, you don't need that calculator. Your brain big enough for this. So, Serena, what this do, right, is, okay, so Serena, do you understand that you could only add the numerators once it's the same denominator? And you know that? So if I want to write minus 25 as a number over 3, I would need to multiply minus 25 by 3
Yeah.
as well. So minus 25 by 3 is minus 75, and
Yeah.
minus 75 minus 16 minus 91 over 3. So if this is a case, Serena, could you tell me what the final answer would be in the form ax plus h squared plus k?
Yes, it would be 3 open brackets x plus 4 over 3 close bracket squared minus 91 over 3.
Yeah, so I think the answer I got was wrong.
No,
Tell me if you understand it now.
the answer that I wrote in the chat when I sent it to you, that answer was actually correct.
Oh,
Yeah. That's what I was saying. She didn't teach us these formulas.
3x plus 8 squared minus 25?
Yeah.
No, that would not that would not work out. Wait,
I could send you the lesson that she taught us because she has it in a document.
wait, let me check something out. 3x plus 8 squared minus 25. So Serena, if this is correct, when I expand it out, what's supposed to get?
You're supposed to get 3x squared plus bx minus 25.
Yeah. So in the interest of time, just plug it in here. So 3 open brackets x plus 8 squared minus 25. Okay, when I expand that, Serena, um, are you getting the original thing?
No, sir.
No, so that's wrong.
Yeah, that's why I wanted to clarify it.
Yeah, no, that answer is really, really wrong. It can't be 3x plus 8 squared minus 25. Yeah. But you know what it could be though? It could be that she factored out x. If you factor out x, that will be 3x plus 8. But I don't know why she would want to do that. Yeah. So that working is wrong. Bring it to her attention. Show her that if you expand it, you're not gonna get the correct answer.
I will.
Say that again?
I said I will.
Yeah, that's crazy though. That's crazy. She told her that was the correct answer.
Yes, and that's how she taught us how to do it too. That's why when you taught it in class, I was a little bit confused.
I'm really feeling bad for you. Um, and even if you do the long way, you still wouldn't get like the answer is 100% wrong. You understand why it's wrong?
Yes, sir.
Yeah, because you're supposed to get back the original quadratic you started with. If I were to expand this here, what should I get back?
You're supposed to get back 3x squared plus 8b minus 25.
So let me see if that's the case, right? Promise I'm not going mad. Watch. Um, what's that? Use this one. Right. So 3 open bracket x plus 4 over 3 squared minus 91 all over 3. Serena, do we get back the correct answer?
Yes, sir.
Yeah. Some serious misinformation way. So you didn't learn these formulas at all.
No, sir.
Zachary and Caleb, ain't you guys learn these formulas in school? Or nah?
Yes, sir.
No, not yet.
Okay. Yeah, Selena, please. I'm not saying Selena. Serena, please go sort out with your teacher because she's giving all the wrong information. You
Yeah.
gotta let me know what she say about it. If she say that her answer is correct, and I don't know what to say then at that point. Do you think your teacher would admit that she's wrong?
Yeah, she's really sweet and understanding, and she usually does. So
Okay, well, good, good. Bring it to her attention. I'm sure she will understand.
yeah, she would, but it's just to teach it over to the whole class again because, well, she kind of taught it wrong in the first place.
Don't know what to say. I want to say that, well, teachers will be tired and thing, yeah? But like, that's a big mistake to make. But yeah, let me know what happens.
Yeah.
Right, so yeah, that's essentially it for completing the square. So when we do in completing the square questions, we typically use the formulas H and K. Now, just to do a quick recap before I move on, guys, do you all remember how you would find the minimum point using the H and K? Minimum or the maximum point? Do you all remember? Do any of you guys remember the minimum or the maximum point?
A value.
Notice I say point, eh? I didn't say minimum or maximum value. But if it was value, it'd be correct, okay, but I'm asking you for the minimum or the maximum turning point.
Uh,
Point.
F, well, X.
Nah, that'll be given by minus H, comma K. So this is the last recap we're gonna do. And then we're gonna move on to something new, right? So this is our recap. So completing the square recap. Completing the square recap. So guys, first things first, what is he completing the square form? That's the first thing we're gonna start off with. What's he completing the square form, guys? Zachary, what's he completing the square form?
The A open bracket X plus H bracket squared plus K.
All right. Next thing, Zachary, what's the formula for H?
B over 2A.
Right? What are the alternate formulas for K? How many two formulas?
You have C minus B squared over 4A.
Right?
The next one is right. The next one is 4AC minus B squared over 4A.
And do you understand that both of them mean the same thing?
Mm.
Nice. Do you know how you would prove that they are equivalent?
I don't think so.
Nah, but we looked at it though. Remember, I showed you how to do it? Check it out.
Yes.
So you run me through these steps. How would I prove that this is equal to this? If for some weird reason they ask that, how would I do that? Just remind me, how would I show that this is equal to this? Do you remember?
Yeah, kind of. So I don't think I could really explain it.
Okay, so the first step is to split the fractions. If I split these fractions, tell me what I would write. I'll split the fraction.
4AC over 4A minus B squared over 4A.
Right? What's next?
You cancel out the 4A.
Right? Just like that. We prove it. That's it.
Well, yeah, right.
So you see on the solid, right?
Mm-hmm.
Cool. Nice. Another thing, right, I need to know. How do you tell if a quadratic is a maximum or minimum?
If A is greater than 0,
If A is greater than 0, it means that you're happy, smiling,
have a minimum point. So
right? So this would be a minimum point. Right. If A is less than 0, we sad.
that maximum point.
Okay, so is everybody okay with these things in class? Are they okay with this?
Yes.
That's it.
Okay. If they ask you for the maximum or the minimum turning point, notice I'm emphasizing on the word point because, guys, remind me, a point is made up of what values?
A X and a Y value.
Right. So you can't just say key, right? So maximum or minimum turning point, and that would be given by minus h, comma, key. What if they ask you for the maximum value? Maximum or the minimum value?
So that would be the key value.
Yeah, that would be equal to key. Caleb, what if I asked you for what value of x? For what value of x does the maximum or minimum occur?
Minus H.
Perfect. What if I asked you for the equation for the axis of symmetry?
Minus H. Well, X equals minus H.
Right? You would say x is equal to minus h. So these are the things that you need to know. And some extra things. Do you all know how to solve for x using the computing square form? Yes or no? Come on one time. Because like this is the last time, this is the last day. I'm gonna do computing square. So if you have any questions and doubts, tell me now. Zachary, do you know how to use completing square to solve for the roots?
Yes.
Okay. Caleb, if you don't know, tell me now. It's okay. It's
I
okay.
don't see.
You know how to do it?
Yeah.
Okay. Do you all know how to find for the y-intercepts?
Yes, sir.
Okay, for the y-intercept is just simply the c value. Y-intercept is c value. Okay. X-intercepts are the roots. Put quadratic equal 0 and solve for x. That's the whole gist of it. So those are the main things you need to know for completing the square. So you all could copy this down one time, right? And we will do as much practice to make sure by the end of today, when we move on, or they don't have any more questions about completing the square. Serena, how are you feeling about completing the square? Be like real honest with me. Like I know it was a bit confused. How are you feeling about it?
I'm feeling confident with it now.
All right, nice. You have any doubts? You have any like things that you're a little confused about?
No, sir.
Okay, good. So as soon as you all have this copy down, let me know, right? Please let me know. As soon as you have that copy down. Caleb, do you have everything copied down, or are you still copying things down?
Almost finished.
Okay, no problem. Zachary, what about you?
Still copying and just down to.
All right. Zachary, if I'm not calling on you much, like Zachary, from a brief interaction we had, I like to think they're really good in ad maths. Or I get a vibe. If if you think I'm overestimating you, tell me, and I'll ask you more questions. You feel like I should ask you more questions? If you say anything, I can't hear. Any of you hearing Zachary? Caleb, you hearing me?
Yes.
Okay, it's Zachary then. I wasn't hearing you.
Well, see, that's put my Wi-Fi, so.
Yeah, so you feel like I should ask you more questions?
Yes, yeah, maths is not really a strong subject of mine.
Okay. I don't know, like I get the vibe they're really good at maths.
So once I understand the topic, I good.
All right. Well, I will definitely ask you more questions. For sure. Like that thing with the fractions. You understand how to split fractions now?
Yes, sir.
So like what if I give you this thing to simplify now? If I tell you 7y squared plus 3yz all over y, how would I simplify that? Think you could do that? Before you say no, think about it. It's the same concept as what I showed you with splitting fractions. How would I split that fraction?
So that would be 7y squared over y plus 3y squared over y.
3yz over y.
Shit, yeah. YZ over y.
Right? What's next?
Cancel all the y's. So
Cancel all the y's.
no, well, so it would be 7y
Mm-hmm.
plus 3y.
Nah, the y would cancel off here.
Huh?
The y's would cancel off here.
So I keep on thinking that z is a squared. So my
Oh,
bad.
shucks. Yeah,
Yes, it's easy.
yeah. So this is a very important trick. You need to be able to split fractions. By the way, Zachary, what are you planning to be? Like when you get older, like what career path are you looking at? You know what career path you're looking at? If you're talking, I can hear.
Excuse that finish.
Okay, okay, nice. Caleb, speaking of which, what is your career path? Like what are you looking into get what are you looking to get into?
Um, I really didn't know, but most likely I engineer.
Eh? So you're looking at suffering like myself. Yeah, 'cause I do electrical. I do my bachelor's in electrical and computer engineering. What kind of engineering you looking at doing though?
I don't.
All right. If you like circuits and programming and stuff and real maths, electrical. Well, all engineering have real maths in it, like real maths. Yeah. I don't know. I feel like you like mechanical engineering. But that's real maths. I think it's my internet connection bad because like okay, you guys hearing me? You hear me now? Guys,
Yes, sir.
Yes, sir.
it's really my internet connection, it's really my internet connection. Yeah, Caleb. Um, like I was saying, whatever engineering field you decide to go into is extreme levels of maths.
Yes, sir.
Real maths. When I say real maths, I mean real maths. Just letting you know that from now. All right. So Serena, I presume you have all the points copied down for completing the square, right?
Yes, sir.
Let's finish your question. Let's add to your question, shall we? So Serena, I'm going to add in parts to this question. So let's do that. So this will be part one, part two. Okay, I need to just verify something before I continue. Did you all do discriminant yet in maths? I mean, maths? Discriminant. B squared minus 4AC.
No, sir.
Okay. We use that to test to see if a quadratic is a maximum or minimum. So when I say maximum or minimum, we use that to test to see if a quadratic will have real or imaginary roots. Just asking, do you all think you could find the square root of a negative number? Zachary, do you think you could find the square root of a negative number?
Nah, sir.
Well, not at this level at least. You actually could. And
Hmm.
yeah, we actually call it the imaginary number. But at this level, no, you can't. Right? So we use the discriminant to check to see if a quadratic has real roots before you get deep into the calculation. So let me just check something out, right? So the discriminant is b squared minus 4ac. Zachary, what's b in this question?
So B is 8.
B is 8, so be 8 squared minus 4. A is 3. C is minus 20. Yeah, that would. This have real roots. Okay, so we can continue then. Find the roots using the completing square form. Okay, so Zachary, if you want to find the roots, right, you're going to let f of x be equal to what? If you want to find the roots, that means that the function is equal to what? Do you know?
So you with me?
Are you guys hearing me?
Nah, sir. I didn't hear.
No, my internet really, really bad. I don't know what it is, but like it's real bad. Are you hearing me now?
Yes, sir.
Yes,
And the
sir.
thing is, I right next to the router too, eh? I right next to the router, so I don't know what's going on. Yeah. So Zachary, if I want to find your roots using the completing square form, I would need to let f of x be equal to what?
0, sir.
Yes. So you see this entire thing here? I'll just put that equal to 0, that's it. So I'll write 3, open bracket, x plus 4 over 3 squared minus 91 over 3. And I'm going to put this equal to 0 because Zachary, if we want to find your roots, another word for roots is the x-intercept. And Zachary, if you're cutting the x-axis, watch. Let's just say I have this line over here, right? If the line cuts the x-axis, if you look at that point, Zachary, what would the y value for that point be? If it's on the x-axis.
0, sir.
Yeah, because you're on the y-axis, right? If you're on the y-axis, you can only move left or right. It have no vertical component, so no y value. Y value is 0. So another way to write f of x is actually y. So that's why when we want to find the roots, we put it equal to 0, in case it was wondering. Okay, so Zachary, the next step. You see this minus 91 over 3? I'm going to take the minus 91 over 3 and I'm going to move it across. So Zachary, if I move across minus 91 over 3, what would that turn to?
So it will be equal to, yeah, that would be equal to positive 91 over 3.
Okay, what's the next step?
Square root, is it?
Not so fast. Before you could square root anything, you need to get rid of the number that's multiplying by the square term. So all I need to do on both sides is to get rid of 3. Right now, 3 is multiplying by x plus 4 over 3 squared.
So you divide by 3.
Yep, you divide by 3 on both sides. So you'll end up with x plus 4 over 3 squared. Now, this is something that gets students every single time. Zachary, by chance, what do you think 91 over 3 divided by 3 is?
So that's 91 over 9.
Yes. Now, guys, where's another way you could think of division? So if you're dividing by 3 over 1, that's the same thing as multiplying by what? What happens when you go from division to multiplication? Do you all remember? Again, this is SCA maths. When you're going from division to multiplication, what's happened to the fraction?
It's flipped.
It is flipped, right?
Mhm.
So dividing by 3 is the same thing as multiplying by a third. So if I multiply 91 over 3 by a third, wouldn't that be 91 over 9?
Mhm.
Yep. So I'm going to write 91 over 9. Caleb, are you lost?
No, sir.
Okay. Serena, are you lost? Serena?
No, sir.
No? Okay. All right. Zachary, what do you think the next step would be? Now that I have freed up the x squared, the squared term, what do you think is the next step?
So now you would find the square roots.
Yes. I would find the square root at this point. So if I find the square root of a squared term, that eliminates the squared term. So now I'm just going to have x plus 4 over 3. Now, Zachary, when you find the square root of something, is it that you only get one answer or you get two answers?
So repeat that.
When you find the square root of something, do you get one answer or two answers?
One answer.
No, two answers. Let me show you what I mean. Caleb, when you find the square root of a number, let me just say you want to find the square root of 25. Do you know what the answer would be off the top of your head?
Yes, sir.
What's the answer for that?
5.
5. And why is that? Why you say that, Caleb? You say that because 5 by 5 is what?
35.
Zachary, and you know that? And you know that, right?
Mhm.
Okay.
Yes.
And that's not the only way you can get 25. When you find the square root of something, you're asking what number by itself would give you the number in question. So, Zachary, a positive by a positive is a positive. What would also give you a positive?
A negative by a negative.
So figure out the other solution then.
So -5 by -5.
Right. So anytime you find square roots of a number, you're really getting two solutions, a positive and a negative solution. Because as you can see, +5 and -5 will both be valid solutions for square root of 25. Because both of them, when you multiply it by themselves, you'll get back 25. So I need to put a plus or minus sign by the 91 over 9.
Mm-hmm.
So square root of 91 over 9. If you have a Casio, the Casio will give you the third in the simplest form. But I don't think we could break down that much. Yeah, we really can't. That's just going to be square root of 91 over 3.
Yes.
Now, guys, we are doing odd maths. Or they think we're going to use decimals, or they think we're going to leave it in the third form.
You said what?
Yeah, we're going to leave it in the third form, right? We long past, working in decimals and things. That is like kindergarten stuff. I mean, we're going a little far by saying that, right? But we don't really round things off in hard maths. We want to stick with the exact answer. So,
Mm.
Zachary, let's look to simplify this surd, right? So if I have the square root of 91 over 9, that means I could apply the surd or the square root to the numerator and the denominator. So Zachary, if at any point in time you're feeling confused, tell me, right? Tell me.
Mhm.
So tell me, is it possible for me to break up 91 into the product of any other two numbers, or is it a prime number?
Nah, so you can't break it up.
Yeah, I can't break up 91, right? I can't really break up 91,
So, yeah, but you could break up 9 too.
right? So I'm gonna leave that as the square root of 91. What's the square root of 9?
3.
Say with me so far, right?
Yes, sir.
You need to consider the positive case and the negative case. So the positive case will be x plus 4 over 3 will be equal to positive root 91 over 3. Now, if you don't see me write positive, it's understood to be positive. It's only if you see a negative sign, then it's negative.
Mhm.
So Zachary, what's the next step?
Minus 4 over 3, sir.
Right? You minus 4 over 3 on both sides,
Mhm.
right? Or you can think about it as moving it across. Either way is fine. So you end up with x is equal to root 91 over 3. Just keep popping up. Yeah, you end up with root 91 over 3, right? Minus 4 over 3. Do they have the same denominator?
Yes, sir.
Right. So I could combine that. If I combine it, what would I write?
Root 91 minus 4 all over 3.
So that's one of our solutions. Could you help me with the negative case, Caleb?
Is this it?
Could you help me with the negative case?
Um,
So x plus 4 over 3 would be equal to what?
x plus 4 over is negative 91 over 3.
Right? We want to find for x, so what shouldn't be on the left-hand side?
4 over 3.
Yeah, that shouldn't be there. So you're going to move that across. And if you move that across, that's going to turn to what?
X equals negative square 91 over 3. Take away over 3.
Do they have the same denominator?
Yes, sir.
Right? If they have the same denominator, you can group together the numerators. So what am I going to write on top? Tell me, Caleb.
Negative square 91 plus, well, yeah, take away 4.
Yeah, and that's it. Right? That's it.
Yes.
Zachary, do you understand everything that we did here?
Yes, sir.
And if we wanted to write our answers to two decimal places, I'm just saying, right? What would this answer be to two decimal places? So somebody plug that into a calculator. Root 91 minus 4 over 3. Right? Or you go tell me what you get for that. Make it the Casio up. So
Um,
square root of 91 minus 4 all over 3. Could somebody tell me what you get? Somebody, I want you all to tell me what you get. Any of you guys, what are you getting for root 91 minus 4 over 3?
1.85.
Shucks. Yeah, 1.85 is correct. Right? Zachary, could you tell me the other answer to two decimal places? Zachary, let me know if you're there.
Yes, I type it in the calculator.
Okay, no problem.
So I get negative 1.03. Probably type it in wrong. So hold on.
A Sharp or a Casio?
Casio.
Okay, I know it's a mistake. Check this, right? So watch this. By chance, is this what you have? No,
Yes.
that's weird.
Well,
Because
it's not true.
Because if you plug it in like this, you're supposed to get the correct answer, which is minus 4.51. Send my picture how you plug it in.
Right, so this.
Serena, you get the minus 4.51?
Yes, sir, I did.
Okay. Zachary, let me know what's going on.
So I think I just typing it in wrong somehow. Just hold on.
Okay, Zachary, let me take it in parts, right? You're going to do exactly what I'm doing. So I want you to press the fraction button. Press the fraction button. Then press the minus button.
Yeah.
Then press square root button. On the inside, you're going to press 9-1. Next thing, you see how the cursor is still inside the square root side?
Yes.
You need to come out of that because it's minus root 91, then minus 4. So you're going to press the right arrow to come outside of the square root sign.
Mm-hmm.
Then you're going to press minus 4. You're going to press the right arrow. Then you're going to put 3 in the bottom. Then press equal. Let me know what you get.
Yes, I get negative 4.51.
You know you was doing wrong before though? Curious.
Yes, so I just wasn't doing all that. I just doing something.
It's all I'm tired tonight. Like it's all I'm frustrated. Everything all right?
Yes, everything all right. Everything all right.
Like you're sounding real frustrated. I don't know. I sense a disturbance in the force. I feel like I sensing something off. Yeah.
Hmm.
Right. So that'll be minus 4.51. All right. Let me add in some more questions into this. So in general, if you get a question where they're asking you to find your roots using the computing the square form, they're gonna put f of x equal to 0. They're going to move across the constants, move across the constant, move across constant. Divide throughout. Divide throughout by a. So Zachary, I hope they're not confusing you, right? Because in this question, what was a? What was a in this question, Zachary?
3.
3. Right? So you understand what I'm saying? Divide throughout by a.
Yes, sir.
Okay, cool. You would divide throughout by a. Then you would square root both sides. And you would consider positive and negative solution. So consider positive and negative solution. Part 3. What is the y-intercept? So guys, what would the y-intercept be for this question?
C value.
Yeah, the c
Yes.
value. The c value here.
Right.
Minus 25. So
Minus 25. The c value is minus 25. So the y-intercept is just simply, so it would say c is equal to minus 25. Part 4. What if they asked, what is the coordinates okay, what would the answer for that be? What are the coordinates for the y-intercept?
Negative HQ
No. Philip,
or XI.
you are talking about the maximum or the minimum point. I'm asking you for the coordinates for the y-intercept.
so
So
it would be 0, -5, -25.
yes. Caleb, at the y-intercept, x is equal to 0 because you're on the y-axis itself.
Yes.
Caleb, consider if you have this line here. You have a line here. You see where it cuts in the y-axis?
Yes.
At the point where it cuts in the y-axis, that point is on the what axis?
On the X.
The x. What axis is this?
Y is right.
If it's on the y-axis, that means the x value will be 0.
Yes.
So, the x value is 0, and the y value in this case would be minus 25. Be very careful about that, Caleb. What if they ask us now for the maximum or the minimum turning point, right? And justify your answer.
Two
Yeah, Caleb?
minus H comma D.
Right. But tell me, would it be a maximum or minimum?
A.
What was
What A was it?
it was 3. It was 3.
It would be a minimum point.
Right. See, so you had to put that right. See, you would say since A is less than 3. What's saying, boy? I'm really tired. Eh? I didn't sleep whole night. Not just going off Red Bull here. Right? So since A is more than 0, right? So Caleb, this is the part where you would put the point. Since A is more than 0, what would the point be? Is minus h comma k ends?
Yes.
Okay. So what did we find h to be?
H 4 or 3
So that'll be minus 4 over 3, comma, minus
minus
1 over 3.
91.
Minus 4 over 3, comma, minus 91 over 3. So you would say since A is more than 0, minus 4, 3 minus 91, 3 would be the what? See if you can finish it, the sentence, Caleb.
Minimum turning point.
Perfect. Serena, you okay with everything so far?
Yes, sir.
All right, so Serena, next question. Um, for what value of x does the minimum occur? Does a minimum value occur at?
-4/3.
Right? It would say negative. Yep, you are correct. What's after VI, guys? Like, if we're talking about Roman numerals, what's after VI? Anybody know? Is it like VII?
So VII.
That's my guess, eh? I'll legit go and pull up Roman numerals right now. Let me see Roman numerals. Are you probably saying, wait, why this man don't know the Roman numerals? uh, all right, so these are the Roman numerals in case I didn't know. I myself forget. Yeah, so it's VII. Okay, Kilo, we crushed it. We got it correct. It's VII, right? VII. What is the axis of symmetry? What is the axis of symmetry?
X equals -H.
Right? And we know H is 4/3, so X would just be equal to minus 4/3. What else could I think that's it, That's all they could ask you. Under completing the square, this covers everything that they will ask you. They will ask you to put it in the completing the square form, that's one. They might ask you to find your roots using the completing the square form, that's two. They will ask you for the y-intercept, that's real simple. They would ask you for the coordinates of the y-intercept probably. They would ask you for the maximum min turning points. They would ask you for the value at which it occurs, and they'll ask you for the axis of symmetry. And the last thing, they will ask you to do a sketch. So let's do a sketch. Sketch a complete graph for f of x. Right. So, Zachary, I want you to help me with this question. So, I'm going to draw my Cartesian plane. By the way, guys, Cartesian plane is just a fancy way for saying xy axis. Eh? So this is y, this is x. So tell me, Zachary, do we know what the roots are for this question? Did we find your roots at some point?
Yes, sir.
Right? Is it that both my roots are positive, or one is positive and one is negative?
One is positive and one is negative.
Right. So this is just a sketch, right? So I can say that this is the 1.85.
Mm-hmm.
And I could say that this is the minus 4 point, where was minus 4.1? It's minus 4.51.
Yeah.
Right? Next thing. We need to like do like a reasonably accurate sketch, right? So the next thing you need to know is the x value for the turning point. What was the x value for the turning point?
-4/3.
Right. Minus 4/3 would come before the minus 4.51 or after the minus 4.51?
That would come
So this is before?
before.
Before, right? Yeah. So minus 4/3 is like minus 1.333. So that might be somewhere over here.
Yeah.
All right. So, and it was a maximum or minimum?
Minimum.
Right. So that would look like this. You okay with that?
Mm-hmm.
Okay. Caleb, you confused by anything at all?
No, sir.
Okay. Caleb, it low-key sound like you like maths. Like low-key. Maybe like low-key. I don't want to say like high-key, but I feel like you like maths to some extent.
Yes, sir.
Right? Okay. So we okay up to this point. Next thing, we should probably put the y value for the minimum point. So do you remember what the y value was?
-25.
Wow, that's like a really -25. You sure? No, it was -91/3. Because remember, Caleb,
Then,
the minimum point would be minus h, comma k. So the x value for the minimum turning point would be -4/3, and the y value for the minimum turning point would be -91/3. Remember, Caleb, and k would
I,
be the minimum value.
yes, that is mix of the value and the point.
Careful about that. So this is -91/3. That is the low. That's like the lowest the graph would go. That's the minimum value, right? And what is the y-intercept?
That is -20.
Yeah, right. So the -25 would go over there. You okay with that, Caleb?
Yes, sir.
And this would be the axis of symmetry. You would say x is equal to -4/3. And this is like the perfect graph. This is like this is as much they can test you on at this level. They can't test you past this. Serena, do you have any doubts or any points of confusion at all?
No, sir.
No? Okay, so before we end class, like I tell you now, this is the last class we're going to do on completing the square. So I'm going to give you all one question. I'm going to give you all one question to do, right now, and you all are going to get it correct. I could bet money on that. I trust all you, right? Zachary, you think my trust? You think my trust is going to be broken or like, you feel like,
That's
oh,
it. You trust. Good, good.
okay, okay. Give me 1 second. I'm looking for a question. I'm gonna like spice up things a little bit, right? But I still think you all could figure this out. I don't think it'll be that hard. I think you'll be able to figure it out. Right. So hmm, one moment. I'm conspiring with ChatGPT against you guys. Serena, I think you're gonna get this question correct. You didn't see it yet, but I think you get it correct.
Yes, sir.
I like that confidence. Good luck, guys. Waiter. Um, Actually, I'll just put it away. Do the question with a blank slate. Try to do the question without looking at anything. So I give it only 10 minutes for this question because I want a good sketch as well. Right, so your time starts now. Give the question a go. Caleb, you think you'll get the question correct?
I think I'll be like halfway this.
Don't say that. Come on, Caleb. Confidence, man. Confidence. You gotta manifest it, you know. You gotta
Yes.
believe it. You gotta believe it. Okay, so you guys getting through?
Yes, sir.
Okay, nice. Guys, is this a maximum or minimum graph?
Maximum.
How much of you all say it's a maximum?
I ain't get it yet.
Say that again?
I ain't get to that part yet.
Okay, you're supposed to know that from the start. So, Caleb, what would tell you if it's a maximum or minimum?
You see.
You see? Oh, let me see.
The ma the maximum minimum points, sir.
No. Look at the summary notes. What tells you if it's a maximum or minimum point?
Oh yeah, yes, if A is more than or less than zero.
Was A in this question?
Negative 3, so that's maximum points.
Yes. Serena, are you getting through?
Yes, sir.
Okay, nice. Zachary, which part did you reach?
On E.
E? Okay, cool.
Yeah.
Right, so after the time is up, you'll have 40 seconds remaining. Send me a picture of what you have so far. All right, so the time is up. Send me a picture of what you have so far. All right, so let me answer this question. All right. So, Caleb, what step did you reach at? Where did you reach? Which one? Where did you reach?
Um, easy. I'm
You,
gonna send it the channel.
all right, so Caleb, it doesn't look bad. Let's do the full question, all right? Zachary, what about you? How did things go on your end? See, delete a message.
I reach FC. I just recently the picture. The picture didn't come up good.
Okay. So Caleb, let me jump straight into it, right? So we have minus 3x squared. Call it out from us. We got minus 3x squared.
Minus 3x squared plus 18x.
Mm-hmm.
Take away 20.
All right, nice. What is A, B, and C?
A is negative 3, B is 18, and C is negative 20.
What is H?
Which is B over 2A, which
Right,
is 18 over 2 by negative 3.
right. 2 by negative 3. What is 18 divided by negative 6?
Negative 3.
Nah, not negative. Oh, yeah. I see. Sorry, like a real tired boy. But yeah, you're right. Be negative because it'll be negative 6, negative 3, yeah. K now. K will be C,
K C take away B squared over 4A.
right? C is minus
So
20 minus 18 squared all over 4. So that'll be a minus 20 minus 18 by 18, I think is 256. No, 18 by 18 would be 324. Yes,
yes.
that'd be 324 over 12. At, at the term 27. Something far wrong.
So I guess 7.
No, I'm talking about this part. Would this be 27?
Oh, hold on.
So that'll be 324 over minus 12. That'll be minus 27, I think. So 18 squared over 4 by minus 3.
That's the minus 27.
And then we have the minus on the outside. So where's our minus by minus?
Positive.
All right, so that's going to be minus 20 plus 27. What's minus 20 plus 27?
7.
Right, so k is equal to 7. So what would f of x be in the completing square form?
A open bracket X plus H close bracket squared plus K.
Right, and what is a, h, and k?
Negative 3, negative 3 plus 7.
Wait, say that again. Negative 3, open bracket.
X take away 3 close bracket squared plus 7.
Perfect. That's the correct answer. You're supposed to get that.
Yes.
Serena, let me see what you got. So Serena, you got the correct thing. Serena, just don't forget to write f of x, right? Because our original function was called f of x. So you'll say f of x is equal to minus 3x minus 3 squared plus 7, right?
Okay, sir.
Yeah. Um,
Yes, I make a mistake.
right. So Zachary, I would actually recommend finding for h and k on the outside and then plugging it in. Because when you do it like that, it leaves like a lot of room for error. Like you could get real error over there. I'd recommend taking the time, splitting it up into parts, and then plugging it back in.
Yes.
Yeah. Right? So Zachary, since you didn't get that question correct, I will have you do the rest of the questions, Omar. You need to lock in, you need to do this. Right?
Yes. I just use the wrong value there.
Part B now. They want us to figure out the turning point. What would tell us the turning point?
That will be minus K.
Nah, not minus.
Minus H, comma
Right.
K.
Right. Is this a maximum turning point or a minimum turning point?
Says a maximum.
Right? Maximum turning point. Because what? Because
Because A is greater than no. Because A is less than 0.
right. And so our
So it will be 3 and 2 are 7.
right, it will be 3. I'm gonna put the full working, right? Is minus h comma k.
Mm-hmm.
And we got h to be minus 3. So that'll be minus 3, comma 7. So that will be 3, comma 7.
Yes.
Caleb, did you get that?
Yes,
Yeah?
yes.
And Serena, you got that too. Great job. Zachary, don't worry. I know you just I know you use a wrong value. But you have to be real careful. And again, I'm telling you, best you do it separately, find for H and K separately, and then plug it back into the form.
Yes. Next time.
Because like you could imagine how like it'll start to look real complicated if you're doing it in one step. Right.
Yeah.
Part two. Well, we already answered part two, right? We already answered part two. They asked us for the nature.
Mm-hmm.
And we said it was a maximum because A is less than 0. So let's just put this as part two, and this as part one. Part C, write down the axis of symmetry. What would the axis of symmetry be?
Easy.
Now, axis of symmetry is an equation.
Oh. So that would be X is equal to 2.
Yes.
Yeah.
Right? Caleb, you were saying something?
But
All right. Yeah. Part D, now find the maximum value of the function. What is the maximum value of the function?
7. So
Right, 7. Maximum value is equal to 7. Part E, find the y-intercept. What's the y-intercept?
minus 20.
Yep. C is equal to minus 20. F, solve the equation. They want us to solve it now.
Yes, I was doing that.
So, but you gotta get the wrong answer because you put it in the.
Yes.
So you gotta be real careful, right? So anytime you do not complete any square question, and they ask you to find your roots, they want you to do it in a specific form. So you're going to write it in a complete any square form. So somebody just remind me, what was the complete any square form? It was what? It's minus 3, open bracket.
X
It was minus 3 or yeah, it was
minus 3
yeah, minus 3 again. Minus 3 squared. Yeah.
plus 7,
And I'll put that equal to what?
0.
Right. What's next?
I had stuff.
All right. So, Caleb, I would implore you to reference these steps. So after we put it equal to 0, what are we gonna do?
Move the constants across.
Divide throughout by a, square root both sides, and then consider the positive and the negative solution. So tell me, what term here is the constant? So
Negative. -3.
Nah, that's not. Okay, so a constant is a number. A
Oh,
constant is a number. A constant is something that doesn't change. It's constant. Think about it like this, right? Um, Caleb, if I have, so you see this term here?
yes,
This term has X in it. You see, now it have X in it.
yes, sir.
Is X a constant or variable?
A variable.
Yeah, so you see that -3 here? That is not a constant because it's involved with a variable.
Yes, so
So the
it's 7.
right. Then we're gonna move 7 across. So I'm gonna say -3, open brackets, x -3 squared, and that'll be equal to,
7.
take your time and correct yourself. It will be +7. It will not be
Is it?
+7. I said correct yourself.
-7.
Right. Zachary, what's next?
Say E divided by A,
Right, what's A in this case?
-3.
Right, so I'm gonna end up with what in the next line.
You will get -7 over -3.
Right, what about the left-hand side? What would I write on the left-hand side?
X -3 squared.
What is -7 over -3? What's a negative divided
7
by?
over 3. So the negatives will be cancel out each other and it will be 7 over 3.
Right? What's next?
Square root them. So
Right? Now, 7 and 3 are both prime numbers. So yeah, you can't really do anything with that. You really can't do anything with that. So you're just gonna leave that as √7 over 3. Right? So you're gonna end up with x -3 squared, and that's going to be equal to, remember, when you find the square root, you always get a positive and a negative solution. So put plus or
you
minus,
put the plus or minus sign. So
right? And since we found the square root, the square is we're gonna get rid of that. So it's just x -3 is equal to plus or minus um √7 over 3. Any question? Did they specify how much the accuracy? Okay, they said give your answer in third form, so you can't round off. Right? You can't round off. So x -3 is equal to plus or minus 7 over 3. All right, so all you with me so far?
yes, sir.
Okay,
Yes,
so let's consider the positive solution first. So that would be x -3 is equal to what, Zachary?
X -3 is equal to positive 7 over root 7 over 3 -3.
Right? What next?
-3, sir. But +3, sorry.
So I'll get x is equal to, and watch this, right? I'm presuming all of you guys would have do surds in school already.
Also, we never do so yet.
That's interesting because surds supposed to be the first topic in our maths. Like one of the first topics is log surds and indices. It's like the first topics is teaching our maths.
Also, the first topic we do was polynomials.
Okay, all right. But watch, √7 over 3, that would be the same thing as √7 over what? What do you think? √7 over
True.
√3,
Oh,
because we're square rooting the entire thing, right? Plus. Now, this is where things might get a little complicated. Actually, I think if you leave it like this, if you leave your answer like this, you should get your marks, but there's more things you could do. And I'm going to show you all the more things that you could do, right? So x is equal to square root of 7 over 3 plus 3. The main thing we want to do is combine it into one fraction. So again, square root 7 over 3 is √7 over √3, right? Plus 3. Now, let's find the LCM for this. What do you think the LCM is, Zachary? If I have √3 and 1, what do you think the LCM is?
so yeah, 3 and 1.
I have √3 and 1.
Mhm. So we treat root 3.
Yes, it would be root 3. How much times root 3? We're going to root 3.
1 time.
Right? Where's 1 by root 7?
Root 7.
Right? Where's how much times 1 could go into root 3?
Root 3 times.
Right? So I'll write that as, so that'll be root 3 by 3, which is 3 root 3.
9.
That'll be 3 root 3. Can't say 9. Right? So this will be your answer for X. All right, let's do the negative solution now. So it's the same procedure, it's just that you're dealing with negative, you're dealing with negative root 7 over 3, right? Plus 3. So gonna skip some steps. All right, because it's the same procedure as the positive, right? It's just that is negative now. Right? So you find the LCM. Again, the LCM is root 3. So it's the same thing as this. It's like the same working. It's the exact same working. It's just that you'll be dealing with a negative sign here. Okay, these are your answers. Now, I will say that if you wrote this, okay, if you wrote this and you wrote this, you'd get full marks. Everything past that is being extra. Are you guys okay with everything I did? Or are you confused?
So I good.
Okay, Killer, what about you?
I'm good, sir.
Okay, Serena, you okay with everything?
Yes, sir.
All right. So we found the X values, right? So this is where you needed to have. And if you wanted to be extra, you could have combined it into one fraction. Yeah. Right? And there was another way you could have worked the question as well. Honestly, it has so much ways you could work the question. Serena, and you would have done rationalization before?
No, sir.
No. Did any of you do SIDS in school yet?
No, sir.
Okay, that's interesting. There's an easier way to work the question. Let me show you what we're talking about. But truth be told, if you had this, you'd be fine. Another way to simplify the question would have been like this. So, Zachary, do you understand that root 7 over 3 is just root 7 over root 3?
Yes.
What you could also do, right? I have a question. If I were to multiply that by 5 over 5, would I change the meaning of the expression? Question, what's 5 over 5?
1.
If I multiply something by 1, do I change the value of it?
No, sir.
No. So there's something called rationalization in surds. And to rationalize a surd, you'd multiply the surd by itself. So, and the purpose of this is to get rid of the surd from a denominator. So let me show you what I mean. So, Zachary, take a wild guess. If I multiply root 3 by root 3, what do you think is going to happen?
Um,
So you're multiplying a surd by itself. So you come like you're squaring it. So if you square something that's being square rooted, what's gonna happen?
It will still be itself.
It will cancel off. It'll cancel off. Because n square and square root is the opposite of each other.
Yeah.
Yeah. So on top, okay, so when you're multiplying surds, they multiply, right? So root 7 by root 3 is just root 21, and root 3 by root 3, since you're squaring a surd, you just get 3, right? Plus 3. And you'd find the LCM here. What will be the LCM here, Zachary?
Jeez.
Right? So 3 into 3 is 1. You're going up with root 21. Right? 1 into 3 is 3. 3 by 3 is 9. So that's the better answer to put, because you'll have to rationalize this. Yeah. Okay. All right. So Caleb, I want you to help me with the other one, right? Help me with the other one. So Caleb, minus root 7 over 3. That's the same thing as minus root 7 all over what?
Minus square root 3.
Square root of 3, right? Now,
Yeah.
if I want to get rid of the square root from the denominator, I will need to multiply by root 3 in the top and the bottom. Why am I choosing to multiply by root 3? I'm choosing to do that because I want to get rid of the square root in the bottom. That's what rationalize means. Rationalize means that you want to get rid of the square root sign from the denominator. So, Caleb, don't you understand that square root and square are opposites?
Yes, sir.
So they would cancel off, right? So if
Yes.
I say square root 3 by square root 3, that's just going to give me 3. So I'm going to multiply the top and bottom by root 3, and I'm going to write back plus 3. So what is minus root 7 by root 3? What do you think? Are we minus?
Minus 21.
Right? And where's root 3 by root 3?
3.
Right? Plus 3. Find the LCM. What would the LCM be?
3.
Right? Because 3 is the same thing as 3 over 1. So the LCM is 3. 3 into 3 is?
What is it?
3 into 3 is?
Oh, 1.
Is 1 by minus root 21.
Minus root 21.
Yep. 1 into 3 is 3. 3 by 3 is?
9.
Right? So these are the perfect answers. Serena, was there anything that I did here that was real confusing?
No, sir.
And Serena, you realize that I multiply the top and the bottom by root 3 over root 3, right? You see that?
Yes, sir.
The reason I do that is because if you multiply something by root 3 over root 3, and technically, and that means you multiply it by 1,
Yes, sir.
think about that. And if you multiply something by 1, are you changing its value in any way?
No, sir.
No. So I trust I understand what I did. So this is the perfect answer. And actually, if you plug it, if you actually do it in the calculator, I think the calculator is supposed to give you this answer. Let's check it out. Do you all know how to solve? Caleb, you were saying something?
I'll say now I had to get any calculator first.
Okay, nice. Because that's the answer, we're getting the calculator. And let's just verify that. Zachary, by chance, do you know how to solve a quadratic using a Casio?
Nothing.
Nah, you're missing out on that Casio goodness. So do you have the same Casio I have?
Yeah.
Okay, I want you to press menu.
Mm-hmm.
Are you seeing these options?
Yeah.
Okay. You're gonna scroll down until you see equation/function.
Until you see. Yeah.
Then press equal.
Mm-hmm.
Then press 2 for polynomial, because a quadratic is a polynomial. Right?
Yeah.
What do you think the degree of our polynomial is?
2.
2, because it's a quadratic, right? Our quadratic is, so we're gonna put minus 3, press minus 3 for A, then press equal. it should input the minus 3. Then you're going to press 18, press equal. You should input the 18 and then put minus 20 for C. Press equal. And you should have the minus 3x squared plus the 18x minus 20. Let me know if you have that.
Yes, sir.
Press equal now and tell me what you get.
Um, 79. Hold on, sir.
So Caleb, you see like it's the exact same thing, right? If I were to just switch this around, it'll be 9 plus root 21 over 3. It's the same thing, you see?
Yes, sir. That right, yeah.
Yeah. So the first answer I'll show you guys is not the optimal solution. This is the optimal solution because you're rationalizing the surd. Your goal is always to rationalize a surd. For some reason, we don't like to see square roots in the denominator. It have a reason for that, but I wouldn't explain that today. I feel like I don't want to confuse you guys, right? But there's a reason for why we choose to rationalize surds. It makes things easier to round off. Zachary, you back?
Yes, sir.
For Zachary, for the first X1, did you get that? For X1, the
Yes,
first,
I get the same answers we get.
nice. So you're feeling content with what we did?
Mm-hmm.
And your Casio also gives you the maximum value as well. Seeing that?
Yes, sir.
Yeah, so it tells you the maximum value. And we actually found the maximum value. Wait, right now they're giving you the maximum value, the X value that would give you the maximum value. That's what they're giving you. So right now, you see a little X? Come if you see any X.
Mm-hmm.
So they're saying X is equal to 3. Press equal again, and it should give you the Y value, which is 7.
Yes, sir.
So you see, your Casio giving you the X and Y value for the maximum point. Did you know that before?
Nah, sir.
Yeah, that Casio have, it could basically do your whole hard maths exam for you and your maths exam, if you know how to use it properly. Caleb, did you get the X value? Did you get the X value to be 3? Like if when you keep pressing equal, I'm not sure if you're the same Casio, do you? Or do you have a sharp?
That's that right, I see.
Okay, so when you keep pressing it, you got X to be 3.
Yes, sir.
And when you press it again, you got Y to be 7.
Yes.
Great. So as you see, the Casio tells you the maximum point and the minimum point. It would tell you it would tell you the maximum and the minimum. Right? Let's continue, right? So now they want us to determine the X coordinates where the curve cuts the X axis. All right, so they want us to figure out the X coordinates. That's not hard. Right? So Serena, yeah, don't worry, you'll get a Casio. Before the year finishes, you'll get a Casio, right, Serena?
Thank you, sir.
No problem. Serena, um, we want to figure out the X coordinates, right? Would that be difficult or easy since we already had roots?
Easy.
Say that again?
Easy.
Easy. So what would the X coordinates be?
It would be. Wait.
Yeah? They want us to figure out the X coordinates where the curve cuts the X axis so that they're just asking us for the roots, right? So tell me. And tell me the exact value. I don't tell me a fraction. I mean, tell me the exact value in surd form.
So root 21 plus 9 over 3.
Right? Come on, what?
Comma negative root
Nah,
20.
nah. If you're a point on the X axis, what is your Y value?
0.
Yeah.
Oh, okay.
Because they look at what they're asking us. They're asking us to determine the x coordinates, right? Where the curve cuts the x-axis. When it cut the x-axis, the y value is 0. Remember?
Yes, sir.
Nice. Right. Zachary, some of the other x-intercept.
So that would be minus the root 21 plus 9 all over 3, comma 0.
Yes. So if they're asking for the roots alone, you're gonna give the x value. If they're asking for the coordinates, you're gonna give them the x and the y value. All right? You hear that, Caleb? X and the y value. So Caleb, I don't know if you understood this question.
Yes, sir.
And Caleb, do you think you'd be able to sketch the graph?
Um, yes,
Yeah or no?
yes, sir.
All right, well, let me see if we can do that. First things first, Caleb. Just so we have an idea, right? What decimal this would be? Root 21 plus 9 over 3. What decimal are we looking at?
Um, yeah. Hold on, I see.
Say that again.
Why do we go back for that?
I'll work it out quickly. So I'll be root 21 plus 9 all over 3. So that would be 4.52. So that we could say that as over here, right? Right. So we can say that as that value over there.
Yes.
Right. And what would
Negative.
if it's negative root 21, that's going to be 1.47. So have a question, right? Is our
Yeah,
graph going to be in the negative quadrant or only in the positive quadrant?
really positive.
Yeah, because both of our roots are positive, as you will see.
Let's see.
Right. So this one over here, this one is approximately 1.47, right? And this one was approximately that one was approximately 4.53.
Yes, sir.
And guys, just remind me, what was the x value for the maximum
Three.
touch point?
Three.
3? Okay. And was our graph a maximum or minimum?
A maximum.
So should it look like that or should it look like that? One or two?
1 or 2.
One or two?
2.
Two, right?
Yes, sir.
Okay. So guys, what would be the maximum value,
7.
right? And what would be the y-intercept,
Minus 20.
right? And the axis of symmetry,
Axis as symmetry. Minus, well, 3, sir.
x is equal to 3, right? Yeah, let's say the
Yes,
equation. Yeah, so if you could handle a question like this, you could handle any question CX you could bring on completely square. You really could. Zachary, if you think you'll need to practice some questions with homework?
Yes, nothing more to practice, but I could do the question. It's just I just think your own value.
uh Don't do that. Don't do that for CXC, you know.
Yes, sir.
Don't do that for CXC. Imagine you know everything, right? And you do that, and you get the whole thing wrong. I would be very sad. I would cry for you if that would help, right? But this is the graph. Serena, you feeling confident?
Yes, sir.
So Serena, is this something that you could do by yourself, like without my help at all, without looking at any material?
Yes, sir. It's
Okay, I
just
like to hear that.
the reason why I didn't do it because I couldn't see the words properly. So I just read
Oh,
like the first line and was going. Yes, so I didn't know how to write it in third form.
or like this, you could not see because the arrow was blocking it or something.
No, it was just too small on the screen. And I tried zooming in, but it didn't help.
Shucks. Well, I'm gonna give you all two questions for homework, right? Two questions for homework. But Zachary, you have any questions at all? Anything you need to clarify?
That's it.
Nah? Okay. Well, that's it for class. Next class, we're going to look at the quadratic formula, as well as determinants. What's the determinant? I mean discriminant. And we'll look at some discriminant questions. That's the plan, that's the plan for the next class. Next class is going to be the last class for the year, right? The last class for the year. So, it was nice meeting two new people, aka Caleb and Zachary. It's nice to meet all you, right? I'm gonna have the last class for the year with you guys just now. Will I have any feedback or anything? Have anything?
Yes, yes, sir.
I say it have any? Will I have any feedback? Like it have anything I could do to better all the experience?
Uh, nah, I enjoy it, sir.
You find it good? It could be.
Yes, sir.
No, I have a metal heart, like you know, like I have it's
Yes, sir. It's good, it's good.
a Zachary. Be honest with me, like it have
That's it.
anything I could do to.
This your class good too, and it is explaining stuff good that makes sure we understand.
Okay, and well, Serena, Serena is my star pupil. I have no complaints with you. He's our boss, certified G. All right. You have any feedback, Serena?
The classes are wonderful.
I'll mama guy and I'll when it's just positive reviews, it is kind of it's like probably I don't know, like when people telling you positive things only is like surely they're saying something about you behind it. I don't know. Maybe I just being too negative there, right? But I'm glad that all you're satisfied. I'm going to send you guys two questions for homework. Zachary, if you get time, do the questions as soon as you could, right? I know
Yes,
you
sir.
do the questions as soon as you could. And my advice is, please, when you're doing H and K, do it separately and then plug it in.
Yes, sir.
Because you see that thing where you're doing it in one step, that you could fumble, it, right? Um,
Yeah.
so yeah, guys, hopefully have a blessed night. Later, everybody. Bye bye.
Bye, sir.
Bye bye.
Bye.